Anything in particular giving trouble?
Number 7, we would just put our calculator in degrees mode or our degree mode into radians and then input it, right?
You would put it into radians mode, yeah. So on 7A, for instance, it says evaluate the inverse tangent of 3 by calculator in radians. Yeah, all you have to do is put radians mode. And then 2, push the keystrokes. Second tangent to get the inverse tangent. 3, some calculators you need to close the parentheses and then push enter. It's no more than that. So that's a real easy one there. Comments?
6B.
6B, all right. If I give you inverse trig function of a trig function of the same sort, inverse sine of sine or inverse tangent of tangent, you can calculate this on a unit circle, right? And what you can do is 7 pi over 6 is a special angle, so I sketch it here. Here's pi, or 6 pi over 6. And then I'll add an additional pi over 6, and then 6 pi over 6 plus pi over 6 makes 7 pi over 6. Here's my angle 7 pi over 6. And the question is, first for the inside, what's the sine of 7 pi over 6? I drop the perpendicular, and I say, well, if this is pi over 6, 30 degrees, this has to be 1/2. This has to be square root 3 over 2, and this is 1. And so the sine is the y-coordinate is -1/2, right? The coordinate, not the position. So this is arc sine -1/2. And now to answer the arc sine question, you're asking, recall, what angle between minus pi over 2 and pi over 2 has this sine? That's the answer to the arc sine. Well, sine is the y-coordinate. So if I draw the horizontal line of all y-coordinates equal -1/2, I notice that one of them is the angle I already have, right? But there's another over here. So the question is, which one is it? Which terminal ray do I pick? One where the angle's between plus and minus 90 degrees, right? It's the one between here and here. Oh, not the one I had before. It's going to give me a different number. The inverse sine of the sine of a number will give you that number back if it's between plus and minus pi over 2. But this isn't, right? So it's going to give me something else. I have to figure out what it is. And here's what it says. It's this one over here. And if I don't want to go around this way to it, I want the angle between minus 90 and plus 90, or minus pi over 2 and plus pi over 2. Evidently, since this triangle is symmetric with this triangle, this also must be pi over 6, which means that going the reverse direction, this angle is minus pi over 6 for clockwise. So first you take the sine of 7 pi over 6 using the unit circle. Then you ask the reverse question, what theta between plus and minus pi over 2 has this sign. By drawing this horizontal line, you find this one to evaluate the arc sine of -1/2.
Between plus or minus pi over 2.
Yeah, this goes back. So the question was, why does it have to be between plus or minus pi over 2? It's for this reason. It goes way back. When we wanted to find an inverse to the sine function, sine looks like that. It doesn't have an inverse function because it doesn't pass the horizontal line test, right? And an inverse function, a function has to have no horizontal line intersecting more than once. So we take the biggest piece of it we can, that no horizontal line intersects more than once, and that goes from minus pi over 2 to pi over 2. we say we can invert that piece of the sine function by flipping it over the line y equals x, which looks like that. When we do, it looks like this. And this one went from x equals minus pi over 2 to x equals plus pi over 2. So this one, when we flip it, interchanging the axes, y goes between plus and minus pi over 2. But that means that every number I put into the arcsine function will give me out an angle between plus and minus pi over 2. That's what this does. It asks the question, what angle has this sign? But the angle can only be between plus and minus pi over 2. If we would have picked this piece of the function, we always get an angle between pi over 2 and 3 pi over 2. So it just depends on which piece we picked and what everybody picked and agreed on us to do between those. Yeah, let's do one like that then. If I asked you this is a good chance, if I give you this in a practice test, I'll probably give you a cosine of the test, right? I don't want you to be able to do all of these. What's the inverse cosine? Cosine, let's say, of minus 3 pi over 4. How about that? So you take the cosine of 3 pi over 4 on the unit circle. It's like that, right? Pi back up pi over 4, back up 45-degree angle. Up the perpendicular. Now I recognize this is 45, 45, 90, so that's square root 2 over 2. This is also, and this is 1. So cosine is the x-coordinate minus square root 2 over 2. I know I'm answering more than you asked here, but now this question is what angle theta between 0 and pi has the given cosine. Sine, it always asks you what angle between minus pi over 2 and pi over 2 in the first or fourth quadrants has that sign. But cosine asks you what angle in the first or second quadrants. And the reason there is that we take the cosine function. So put this, which one has cosine equal minus square root 2 over 2? Let's finish this real quick. And this one is, we want the x-coordinate equal minus square root 2 over 2. So it's this line here. And so there's 2 points on the unit circle that have that cosine. It's this one or this one. Right? Which one is it? Oops, except I drew this wrong. I drew 3 pi over 4 instead of minus 3 pi over 4, didn't I? This is the one I should have drawn. Minus 3 pi over 4 was this one. And it leaves another minus pi over 4 here, sorry. So the cosine of minus 3 pi over 4 was cosine of this one was dropping the perpendicular. X equals minus square root 2 over 2. And I get that. But now if I want the arc cosine, what angle between 0 and pi has cosine equal that same number? We draw the vertical line and there's actually 2 terminal rays. And now it could be maybe this angle or this angle or this angle. It has to be the one that's between 0 and pi is the rule. So it's this one right here. And that's plus 3 pi over 4. So the inverse cosine of the cosine of minus 3 pi over 4 is actually plus 3 pi over 4. Ideally, an inverse function, if you take f inverse of f of x, you should get x back, and you do if the angle is between 0 and pi. But this angle is not between 0 and pi, and so we have to use the unit circle, and we find out actually you get back plus 3 pi over 4 instead of minus 3 pi over 4. But the reason I started to say over here is that when we do the cosine function, it looks like this. It doesn't have an inverse either because it fails the horizontal line test. Horizontal lines intersect more than once. So we take this piece of the function. It's just what was decided a long time ago by somebody. 0 to pi. And we find the inverse for this piece that no horizontal line intersects more than once. And we would flip it over the line y equals x. This is y equals cosine. we get the inverse cosine. If you think about it, just flip the axes like that, and this one comes up and looks like this. And that's what we call the arc cosine of x. And this one went between 0 and pi on the x-axis, and when you flip it, it now goes between 0 pi on the y-axis, which means it outputs the angle it has, that cosine that's between 0 and pi. So the inverse sine problem is to find an angle in the first or fourth quadrants because we flip this piece of the sine function minus pi over 2 to pi over 2. But the inverse cosine problem is to find the angle in the first or second quadrants because we can flip this piece of the cosine. So it's tricky. And then inverse tangent is first or fourth quadrants like the sine, except you don't allow equality at the end. So inverse tangent, inverse sine use first and fourth quadrants. Inverse cosine use first and second quadrants. Just because of the piece of the function that we flipped to get the inverse. All right, so that's that kind of problem. Well, this is kind of tricky to have inverse cosine and cosine, but you can do it in the unit circle. What's actually amazingly easier in some ways is for instance, something like this. This one is not so easy. Let's do 6a. Suppose I wanted to take the tangent of the inverse cosine x over x plus 1. That's what this one says. Now instead of same function as inverse, I have two different functions, but if it's a trig function of an inverse trig function, I have this following trick. For this case only, trig function of inverse trig function, I have a 1, 2, 3 method. I can, one, make a right triangle with the inverse trig function that's here. Theta equals arc cosine x over x plus 1. That's step one. And in a triangle, this is equivalently cosine theta equals the given number, x over x plus 1. Here it is. Cosine, I can interpret this as the adjacent side, and this is the hypotenuse of some triangle. So here's, if this is theta, this can be x, and this can be x plus 1. That's what you do for trig function and inverse trig function. They don't have to be the same one. Then two, use the Pythagorean theorem to complete the triangle. What's this side? Well, it's a leg, so it's the square root of hypotenuse squared minus the other leg squared. By the Pythagorean theorem, solve for a leg. Root x plus 1 squared minus x squared. We did one very similar to this before. When you square this out, you have to FOIL. X plus 1 squared is actually x squared plus 2x plus 1. Multiply x plus 1 times x plus 1. All right, you take x times x and get x squared. Then 1 times x and 1 times x is 2x. 1 times 1 is 1. So I use that in here. And then minus x squared. So that's the FOIL in here. Now the x squared and the minus x squared cancel, and this just is square root 2x plus 1. Finally, on step 3 on this one, you evaluate by the triangle. So by the triangle, we'll say that the tangent of the arc cosine of x over x plus 1 is the tangent of theta. That's how I picked theta. The tangent is the opposite over the adjacent in the triangle, so it's got to be square root 2x plus 1 over x. And amazingly, a trig function of an inverse trig function always comes out to be an algebraic expression. You can evaluate it exactly. Any inspiration come that you want to look at? Find some of these. After class, about 12:30, I'll be down at the end of the hall if you want to come take any questions down there, or I can see you online. I'll be online at the same time, yeah.
Go over again why the inverse function is the same as the regular cosine function. Like right there where it says like the inverse is x over x plus
Okay,
1.
yeah.
Same as x.
Yeah, so why are these equivalent? The idea is you just take the cosine of each side. If theta is equal to the inverse cosine, then you take the cosine of theta must be equal to the cosine of the inverse cosine of x over x plus 1. So if these two are equal, then their cosines are equal. But the cosine of the inverse cosine, this is for a positive number, this is in the first quadrant. These undo each other, and so this cosine and inverse cosine undo each other and just give you x over x plus 1. That does make the assumption that this is positive. If this is actually a negative number, then you have to be careful. However, if this is a negative number, consider that separately. We'll just leave it. In other words, in order to get to be technical, we would have to consider x negative also, and I haven't done that. Good. On the test, we'll just assume x is positive for that to avoid having to do a separate case. All right. Well, how about this one? This is 5a. I'm going to ask you to do some inverse trig functions, and this is the hardest one if I ask you to do inverse tangent. What's the inverse tangent of -1? Not enough of these, you can kind of guess it, actually. I find that. We're asking what angle tangent it has to be between -pi/2 and pi/2. Now, I may have asked degrees on this one. I said in degrees on this one. We'll say between -90 and 90 degrees as this tangent. Well, how do I solve tangent equal -1? I don't know how to do that. That's the tricky one. Yeah, it's a special angle. You might be able to guess it. The x and y have to be equal since tangent, except one negative. Since tangent is y over x is one way to think of it. If you rewrite it as a quotient and then divide top and bottom by the root sum square, -1 squared plus 1 squared square root is square root 2, you'll get a point on the unit circle with the same tangent. So you get -1 over square root 2 over +1 over square root 2. And this could be y and this could be x on the unit circle. Right? So it has the same ratio, but this point will be on the unit circle. Now there's one more possibility too. I could divide the top and bottom by minus square root 2 and get this. 1 over square root 2 divided by -1 over square root 2. And this could be y and this could be x. right? But if I want the arc tangent, I have to get an angle between plus and minus 90. So I look at those on the unit circle. X could be negative 1 over square root 2 and y positive 1 over square root 2 would be over here. So this terminal ray has tangent equal to negative 1. It just splits the axes. The x and y coordinates are equal, so their quotient is, except one's negative. So the quotient is negative 1. The other one is over here. This is the one, x equals 1 over square root 2, y equals minus 1 over square root 2. So the two opposite angles always have the same tangent. And then you're asking, well, I'm asking for the angle between plus and minus 90, so I throw this one out. It must be this one. But what angle is that? Remember also, by rationalizing the denominator, this is the same as square root 2 over 2 minus square root 2 over 2, right? These are equal. I just multiply by square root 2 over square root 2 on each of them. And I recognize, oh, that's just a 45, 45, 90 triangle. This angle must be pi over 4 negative since it's clockwise. The answer to this one is minus pi over 4. Or 90 degrees minus 45, yeah. Wants to be able to do graphs.
It's 3B.
Okay, yeah, let's look at 3B. So it says to sketch y equals minus 2 tangent pi x minus pi over 4. On the interval, in particular, minus 7/4 to 9/4. Now, I don't pick those numbers recklessly. I try to pick them like 2 periods apart or 4 periods apart, some even number of periods apart, or at least a period and a half apart. How can I sketch that on that interval? We treat this as an A tangent Bx minus C plus D, so I'll put plus 0, and then I can call D equals 0. And the idea is from the 4 letters, you can deduce 5 properties. One, you can get the vertical stretch. Sine or cosine, we'll call it amplitude, but we'll call this for this one stretch. Same thing, just without the name. Is absolute value of A must be 2. 2, the period, is always 2 pi over B. Except for tangent, right? For the trig function, sine, cosine, secant, cosecant is 2 pi over B. For tangent, however, it's pi over B. But you just memorize all these properties are the same for all the functions, except that tangent and cotangent have period pi over B instead of 2 pi over B. Well, this is pi over pi. This function has period 1. It repeats every unit. Then we ask, is there a flip? Yes, because A is negative. Then there's a shift point, right? A horizontal shift, B shift of C over B, always, and a vertical shift of D. But this works for all 6 trig functions. You just memorize. The vertical stretch or amplitude, whatever you call it, is absolute value of A. Period is 2 pi over B, except for tangent and cotangent pi over B. The flip is yes if A is less than 0, no if A is greater than 0. Horizontal shift is C over B, vertical shift is D. It's all the same algebra graphing techniques, just to start with a different period on those 2 functions. But now I've got it. What you usually do on these things, what I find easiest is to do the shifts first and find the shift point. C over B, let's see, that's whatever's subtracted here, so it's plus pi over 4. Over B is pi. And be careful with these things and these quotients. Let's write them as quotient of two quotients. Pi over 4 over pi over 1. Top times bottom is pi. Over middle times middle, 4 pi. The pi's cancel. Think of the top as pi times 1. And you have 1/4 for the horizontal shift. The vertical shift D is evidently equal to 0. We just read it. And now we've got all the numbers we need. So do the shift point first. Go horizontal shift of 1/4. Vertical shift of 0. There's the shift point, 1/4, 0. For tangent, what you want to do, the easiest way really is to go half a period on each side, right? There's asymptotes every period. So you go half a period on each side. The period is 1. And so what I'll do is I'll go half a unit this way. 1/2 period is just 1/2 times 1 is 1/2. And I'll draw an asymptote right here. Well, what is that point? If I go 1/2 left of 1/4, this must be minus 1/4. Then I'll go half a period this way, also equal to 1/2. If I go 1/2 right of a quarter, I must be at 3/4. There's where my asymptotes are, minus 1/4 and 3/4, and it crosses at 1/4 here, if I can draw this correctly. Now, usually tangent would then look like this, right? It's a wiggle that comes down through the middle point of the middle here. But I flipped it upside down, so I need to draw it like this. So there's a flip tangent. Never quite touches these asymptotes. An asymptote is a line that the curve gets closer and closer to. Right? So it gets closer and closer to. Horizontal asymptotes functions are allowed to cross, but this one doesn't. This is just getting closer and closer. And it goes through this shift point here. Now, the only question left is, how do I draw the steepness? Like, what's this crossing right here? I wonder what that is. Any idea? Well, this point at 0 is halfway between where it crosses its middle line here and the asymptote, which means this corresponds to the, on the tangent function. Let's remind you. If you go to the point halfway between the asymptote at pi over 2 and 0 for y equals tangent, this is pi over 4. You go up 1 unit, right? Because tangent pi over 4 is 1. It follows that when you stretch this thing, the height you go up at the halfway point here is whatever the stretching factor is. So the stretching factor was 2. This point here must cross at 2 because that's the stretch factor. So halfway between where the tangent crosses the middle and the asymptote, it should have the value stretch factor here, and minus the stretch factor here at 1/2. Let's see, 1/4, 1/2, 3/4. Yeah, so 1/2 in the middle, half. It should be at minus 2 units down. So that's how steep you draw it. According to the vertical stretching factor, halfway between the asymptote and the middle point there. All right, so that's y equals minus 2 tangent pi x minus pi over 4. Then you can check it on your calculator. That's only 1 period. Technically, you should put dot, dot, dot to indicate it repeats. Oh, and it's not finished. The next question is, I'm supposed to plot this on minus 7 pi over 4 to 9 pi over 4. I didn't do that. But it should be a whole number of periods. I'll try and give you one that has a whole number of periods. So what do I do to catch it from minus 7 pi over 4 to 9 pi over 4? Well, it's got period 1, all right? So I just go over 1 more unit here. From minus 1/4 to minus 5/4. There must be another asymptote. and another wiggle that looks like that. And let's see, I need to go to -7/4. Well, that's too far. That's, one more period is too far. That's half a period to the left here, so it actually just goes like this. In other words, this is 1/4 and 1 unit over is -3/4. One more unit over is -7/4. It's a crossing point here. So I'll sketch it from here, -7/4 down. 2 periods left of this crossing point here. And then I can go over to 9/4. Let's see, if this is 1/4, then I've got another crossing at 5/4, one more unit over. One more unit over at 9/4. It's gonna be a crossing point here, so it's gonna go like that. There's the graph from -7/4 to 5/4. It's apparently 1, 2, 3, 4 periods exactly. That's what I asked for in that problem. But on these problems, you just look at it. A is the letter that multiplies the trig function. B is whatever multiplies x. C is what's subtracted from bx, and D is what's added on in the end. And you just figure out these same properties the same way, just with pi over b or 2 pi over p for the period, depending on the. Yeah, that's a good one there. Well, you can go the other way too. We'll go take a look here at number 4B. This is a good chance I'll give you something like this. This time I'll give you the picture and find the equation. I forgot to give one more thing of this too. On this handout, I did not include the additional problem. I said, let's see, this was 3B. I also said, what is the period? What's the period of this function? Well, we calculated along the way, right? It was just period 1. And find equations for asymptotes. What are the equations for the asymptotes? Well, you just get the x coordinate and a vertical line is just x equal that number. So the asymptotes are x equals, and here's one of them, 3/4. X equals 3/4 is one asymptote. How do I get all asymptotes? Plus k periods, k times the period. So wherever one of them is plus k times the period, so it's x equals 3/4 plus k times 1 in this case. 3/4 plus k gives every asymptote. Here's 3/4, 3/4 plus 1 is 7/4, that's this one. Plus 1 more is 11/4, and you can go this way from 3/4 to -1/4 to -5/4. So every unit, there's another asymptote. So the asymptotes are just any one asymptote like x equals 3/4 plus k periods. And then finally, we said, what's the domain and range of this? What's the domain of this function? If it's sine or cosine, you just say all real numbers, okay? Because you can take the sine or cosine of any angle. But tangent, not so. All 4 of the other functions, not so. Tangent is defined except where there's an asymptote. So the tangent domain here is all x except the asymptotes. It's x not equal to 3/4 plus k. Those are the x values you can put in, but it's undefined. Those are the x values you cannot put in. It's not defined there. What's the range? You look at the graph and you'll say, what y values can take on? This one goes up and down forever. So the range of this one is -infinity to infinity. So picture, I guess. So there's that one, because you can get all y values, but you can't get these x values that are asymptotes. All right, here's the next one. This is kind of tricky. We've got a sine wave, so you can model it as a sine or a cosine. And I give you a couple points on it, 3 points actually. Here's a point here. Pi over 4, 0. Here's another point in the middle, 0 minus 2. And here's another point, minus pi over 4 minus 4. And I say this is a sine wave. Find the equation. In the last example, I gave you the letters essentially, and you had to find the properties. But here from the graph, I start with the properties and find the letters. All right, so you can pick actually any, the shift point has to be on the midline. So if you look at it, the midline is going right through here. I can pick this as the shift point, or I can pick this corresponding to this minimum, a shift point here, or I can pick corresponding to this maximum, the shift point here. But the shift point has to be on the midline, either where the graph crosses the midline or where there has a maximum or a minimum, a point on the midline. The easiest thing to do, I think, would be to pick this one right here as the shift point, because then it's going up through that point, it's a sine function. So if you pick it on the midline, you use sine. If you pick it, the shift point corresponding to a maximum or minimum, then you use cosine. So we'll say use sine function rather than cosine with the shift point that's on the midline. 0 minus 2. And since it goes up through that, it's unflipped. If it goes down through the shift point, then you flip it upside down, you have to take a negative. Now, how can I get this information? I need the 5 properties to apply, right? The shift point tells me that this is always C over B, and this is D. So I have C over B equals 0, and D equals -2. So I have D immediately, and I have the ratio of C to B. Now I'll use the other properties to do to the rest of the letters. There's 5 properties, right? You've got the horizontal shift, the vertical shift, the period, amplitude, and whether it's flipped or not. And I'll just use those to deduce all the letters. All right, now the amplitude. What's the amplitude? Yeah, the amplitude is from the midline to the distance between the midline and the top, or the midline and the bottom, and it's always positive. So it's, yeah, it goes from -2 to 0, it's 2, or it goes from 0 to, let's see, yeah, -2 to 0, or from -4 to -2, it's 2. So the amplitude is the absolute value of A has to be equal to 2. And we said this is an unflipped sign since it goes up through the shift point. Unflipped sign tells us that A equals +2. All right, now the period we observe from here, what's the period? This is trickier. We don't have a period mark, but what we do is have a minimum here and a maximum here. It goes half a period from here to here, right? And then another half back down. So we observe that 1/2 of the period is equal to the difference in the x coordinates, pi over 4 minus the negative pi over 4. that says 1/2 the period equals pi over 2. It must be that the period is pi. Right, if half the period is half pi, then the period is pi. But the period, remember, is for a sine wave is 2 pi over b. Technically, I should put the absolute value on here, but we'll assume b is positive in all these problems. If 2 pi over b is pi, then I'll take reciprocals and say, oh, b over 2 pi is 1 over pi. Reciprocal of each side. Then multiply by 2 pi and get b equals 2. There it is. So I've got b, I've got d, I've got a. All I need is c. Well, c over b is 0 from the phase shift, and b is 2, says c over 2 equals 0. Oh, evidently c equals 0. So now I've got it. I just write y equals a sine bx minus c plus d is the general form, with a equal 2, b equal 2, c equals 0, and d equal minus 2. There it is. Y equals lots of 2's. 2 sine 2x minus 2 is how it simplifies. Now, depending on how you did this problem, you can get a different answer. If your answer is different than the back, it's just fine often. It depends on what you get. But you can add any multiple of 2 pi in here and it's the same function. So alternatively, you could have y equals twice sine of 2x plus any multiple of pi, 2k pi, with k any integer. That's just as good. Any of those, if you pick your shift points over here, you get plus 2 pi in here. Or if you shift it half a period and flip it upside down, you can put y equals 2 sine 2x plus pi plus 2k pi minus. So I'll shift it half a period and flip it upside down at minus 2. Or you could use cosine. Let's not do cosine also, but if you would have picked one of these 2 points, you'd have a cosine. And your answer could still be right. So be able to do those both directions. We did the word problems last time. Do you feel comfortable with those still? Everyone how to do those? Or a number of others here. I think maybe we should do 3A real quick then if you don't have a preference. We try that one? The secant. Suppose I asked you to sketch y equals 4 secant x over 2 plus pi over 4. Sketch on the interval minus 7/4 plus 9/4. Oops, I wrote the wrong one. Sorry to copy from the next line. Here minus pi over 2, 3 pi over 2. Copied this wrong too. This is pi over 4. There we go. How about this one? So the problem is to find the period. Equations for any asymptotes. And find domain and range. How about that in sketch? So to sketch a secant or a cosecant, first sketch the corresponding graph with the reciprocal trig function. First sketch y equals 4 cosine x over 2 plus pi over 4. Same numbers, just the reciprocal function. And then what you do is touch the peaks and valleys of the reciprocal function. And put asymptotes for the secant, where this function crosses its midline. Touch peaks and valley bottoms. Okay. So pick off A multiplies the trig function, B multiplies X. I wrote this X over 2 is 1/2 X, so we can pick off B easier, right? So X over 2 becomes 1/2 X, and B is 1/2. Now C is what's subtracted, so think of this as a minus a negative pi over 4, right? And C is actually negative here, negative pi over 4. And then D, there's nothing written on the end, so you put a +0 and call that D. So there's A, B, C, and D by reading, and I'll sketch cosine first before I sketch secant. And you just use the 5 things we did before. We'll say the amplitude is absolute value of A is 4, period is 2 pi over B since it's a cosine, 2 pi over 1/2, right? And the 2's don't cancel, you be careful here, right? Right, this is 2 pi over 1 over 1/2. Top times bottom is 4 pi over middle times middle is 1. The period is actually 4 pi. How about that? Is there a flip? No, because A is positive. 4 is greater than 0. Then the phase shift, the cosine, is always C over B. C is negative, right? It's what's subtracted here, negative pi over 4. And B is 1/2. So again, then you do the quotient. The quotient top times bottom is minus 2 pi. And middle times middle is 4. And so the phase shift is minus pi over 2. And then the vertical shift is D is 0. So let's try that. There's the 5 properties from the 4 letters. Start with the shift. Draw that as a shift point, minus pi over 2, 0, and put it right here. Now the amplitude is 4, so I go up 4 units. That's a guideline. And I go down 4 units to another guideline. The period is 4 pi. So I start from here and go over 1 period from the shift point. Adding 4 pi to minus pi over 2 puts me here at minus pi over 2 plus 4 pi. Right? Shift point plus 1 period. Well, let's see, to add these, you have to do quotients. Minus pi over 2, put them over a common denominator. This is 8 pi over 2. And apparently this point is 7 pi over 2. That's 1 period later. Then you take your cosine function and you say it starts at the top guideline, right? Since the sine function goes through the shift point, but the cosine function starts at the top guideline if it's unflipped or the bottom guideline if it's flipped. So unflipped cosine starts at the top, just above the shift point. Start of shift point, top guideline. Right here, well, if it's a shift point, its x coordinate is minus pi over 2. Since it starts at the top guideline, its y coordinate is 4. There's an exact point on this cosine function, right? This is just the shift point, it's not part of the graph. Now I go over one period to here, and we computed the x coordinate is 7 pi over 2. Since one period has passed, it's also on the function, it must be still at 4. So there's 2 points on the exact cosine. Now, what are 3 more exact points I can plot on this if I want? Well, I could get the one halfway in between minus pi over 4 and 7 pi over 4. I just average them. You can do that if you want. Minus pi over 4, 2, plus 7 pi over 2, all over 2. You average them and you get 6 pi over 2 over 2 is 6 pi over 4 is 3 pi over 2. So halfway in between here is 3 pi over 2, and you get down at the bottom, this point, 3 pi over 2 minus 4. And the graph of the cosine then goes down to this point, back up to this point. And where does it cross? Where does it cross the midline here? This is actually important in this problem. I get our 5 points here. What's this point right here? Where it's halfway between the maximum and the minimum. So if this is minus pi over 2 and this is plus 3 pi over 2, this must be pi over 2, right? Halfway between minus 1 and 3 is plus 1. So minus 1 pi over 2, plus pi over 2, plus 3 pi over 2, halfway in between. You can average these 2 coordinates again. And so this actually crosses at pi over 2. The reason this is so significant is where the cosine crosses its midline, the secant is undefined, right? The cosine will be 0 and the secant will be undefined. So now we can draw an asymptote right here at pi over 2. Furthermore, it crosses here, halfway between 3 pi over 2 and 7 pi over 2. What's halfway between 3 and 7 is 5, right? 3 pi over 2, 5 pi over 2, 7 pi over 2. So this is 7 pi over 2, 0, the other crossing point. And where the cosine crosses the midline, the secant will have an asymptote. X equals 7 pi. And now we've got it, right? Well, we want to sketch it on minus 5 pi over 2 to 3 pi, but we'll do that in a second. The graph, what it does is it just touches the peaks of the mountain and heads, I had the blue pen, and heads up towards the asymptote like that. Just touches the bottom of the valley and heads down towards the asymptotes like that. As the peak of the mountain go up. There it is. There's the secant we wanted to sketch. Y equals 4 secant x over 2 plus pi over 4. But I said sketch it on minus 5 pi over 2 to 3 pi over 2. You can bet again that I made this in a whole number of periods. Let's find out what it is. Here's 3 pi over 2. Apparently I didn't need the rest of this. But I can still use this to keep sketching because I know it's periodic. The cosine is going to keep going. Let's see. So this is pi over 2 minus pi over 2. The next crossing point must be minus 3 pi over 2, right? Right? It's pi over 2 to minus pi over 2 is pi units here. Then another pi unit here takes you to minus 3 pi over 2. And then another pi units takes you down to the bottom at minus 5 pi over 2. So pi, 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 pi. It's just the same increment from the midline to the maximum, to the midline, to the minimum, to the midline, to the maximum, each one is pi. So I can sketch the cosine now on minus 5 pi over 2 to 3 pi over 2, and I don't need the rest of this. Because I just wanted to sketch on this interval. And now you notice that by doing that, I actually sketched one period from here to here. All right, so that was a long thing just to get the cosine, but now we've got it essentially because we just want to sketch the secant. Everywhere we have a cosine crossing the midline, the secant's undefined, so at x equals minus 3 pi over 2, there's an asymptote. And then we touch the bottom of the valley, we touch the peak of the mountain, and we don't need this anymore. 3 pi over 2. So we can now take the eraser and get rid of all this stuff. So there's the sketch like that. Sketch was part of it. Along the way, though, we found the period was 4 pi. We had period equals 2 pi over b. We computed was 4 pi. And then what's the domain? That was part of the question. What's the domain of this function? So sine or cosine, their domain is just all real numbers. You can put in any number and evaluate the sine or cosine. All the other trig functions, they're defined except where their domain is everywhere except the asymptotes. So I just avoid the asymptotes. I pick any asymptote I want, x equals pi over 2. And add the distance between asymptotes here. So it's the next one is at, well, here's one. 2 pi apart, right? Should be 4 pi apart, right? Oh, no, there's half a period, yeah. So the asymptotes are 2 pi apart, and so I've got pi over 2 plus k times 2 pi, or 2k pi would be better. The way it's usually written. But it's always for the secant, it's the one any asymptote you want plus k half periods, because there's an asymptote every half period. But you can see where they are from the graph. There's the domain is x not equal to those. And the asymptotes is x equal to those. Those are the x coordinates that are allowed to put in. The asymptotes have equations. X equals pi over 2 plus 2k pi. And then finally the range. What's the range? The range is a strange one here. What's the range? The range is easiest to figure out from the graph. What y coordinates actually here appear on the graph of the blue function here, which is the secant. Yeah, negative infinity, negative 4 up to here, and then 4 to infinity. So you can write it like that. You can say x less than negative 4 or x greater than 4. That would be one way to write the range. You could alternatively write negative infinity to negative 4, union 4 to infinity. Oops, including 4, you have to put a square bracket. When you include the point, you put a square bracket. Infinity and minus infinity are not numbers, you don't include those. 4 to infinity with a round bracket on infinity, include 4 at the other end. That's another way to put it. So or if you use the inequality notation, put union, which means the same thing, for intervals like that. If you want, you can sketch it on the number line. Any one of these three answers will be right. You can sketch from negative 4 and shade it this way, or you can sketch from positive 4 and shade it this way. But these are the y values that could possibly come out for the range. All right, so that's one of the longer ones in the whole thing, I think. Heard me out doing that one. All right. Feel comfortable with all of those? Can you graph all the functions and find their domain and range and Then given the graph, find the equation, be able to evaluate inverse trig functions, inverse trig of trig and trig of inverse trig, calculators and applied problems. I think we've pretty well covered all these. I hate to start the new material now. I'll just have to repeat it in a week. So I think we'll just do review today. I do want to start chapter 7 soon. We'll start it when we get back. Maybe I'll do one more here. Do you have a preference? I'd love to do something you've been having trouble with it. Yeah. Yeah. Okay, let's look at number 2. Find the amplitude and period in an equation for the graph. Those will be somewhat similar to one of the later ones, but the graph is a little different. So there's a little trick in here that wasn't in the other one. I'll try to reproduce this graph on here. Find an equation for the graph. Amplitude and period. If it looks like this, it's evidently a sine wave. It's like that. And this first one right here, if you look, you have to find exact points on here. You can see that it goes through minus pi 0 right here. That's on the graph. And it also goes through pi 0. And if you look at this, it goes up to 2 and down to y equals minus 2. You just have to pick that off, but you can see the exact points. Now, what could be the equation for that one in the amplitude and period? The amplitude is easy, right? What's the amplitude? Yeah, 2. Yeah, it's the distance from the midline to the top or from the midline, between the midline and the bottom. It's always positive, so it's 2 units because it goes from 0 to 2, right? Distance, midline up to the top. Sideline. What's the period? This is the trick. It's hard to get exact points in the middle, but you've got these 2 at the end, and you got 1, 2, 3 whole periods. So we notice that 3 periods equals the distance from here to here, pi minus pi, or pi minus a negative pi, the difference in the x-coordinates, says that 3 periods equals 2 pi, right? So from here to here, it's 2 pi, and there's 3 periods. That says that the period is 2 pi over 3, exactly. So I've got the period and I've got the amplitude. Now, again, like on the other problem, we can do a shift point and get the 4 letters from the 5 properties. We'll aim for that. Again, there's an infinite number of answers depending on what you pick for the shift point. Just for simplicity, let's call this the shift point. Suppose I choose shift point minus pi 0. Why is that a nice one? You want one that either corresponds to a crossing of the midline or to a maximum. I could pick this one, but I don't know what this one is. It's hard to see it on the graph. I can figure it now that I know the period, but why not use one that's marked? Or I could use this one. That one works just as well. It doesn't matter. Well, I'll choose that, and then C over B is minus pi, and D is equal to 0, because that's what the 2 coordinates are, right? Now, from the amplitude, also I'm going to say, if I choose this point, I notice it's coming up through the shift point, so I want to choose a sine function, not a cosine. Choose cosine if the shift point corresponds to a max or min. Choose sine if it's on the midline where the wave goes through. This is a sine right side up since it goes up through there. If it comes down through there, it'd be a flip sine. So choose this shift point, and at the same time, I have then automatically selected an unflipped sine function. Because it's coming up through the shift point. All right. Now that being the case, I notice the amplitude is equal to 2. So absolute value of A is equal to 2 from the amplitude. But it's unflipped. Tells me that A is equal to plus 2. It has to be plus or minus 2 from the amplitude. Since it's unflipped, A is plus 2. Well, I've got A, I've got D. I've got C over B. I get B from the period. I'll say the period was 2 pi over 3. So 2 pi over 3 is the period. But the period is always 2 pi over B. We'll assume B is positive because we can always work it that way. If we don't, we have to flip it horizontally. Oh, if 2 pi over 3 is 2 pi over B, that tells me immediately that B must be 3. Right? Those sides match. And now that I know B and I know C over B, I got C over 3, C over B is minus pi. And I multiply by 3, I get C equals minus 3 pi doing it this way. All right, A, B, C, D, I have it, unflipped sign. I've got Y equals A, which was 2. Let's write it out. A sine BX minus C plus D. Some books like to use plus C, and then they'll say the phase shift is minus C over B. I'll just warn you about that. Some books will take minus the C that we do. It just depends on the text you use. Becomes Y equals 2 sine 3x minus a minus 3 pi plus D was 0. And you can simplify that, right? Y equals 2 sine 3x plus 3 pi. Now, if we go look on the back, it's probably not what it says. Yeah, oh yeah, because it goes through 0, 0 in the middle. Okay. So this works. Yeah, there was another exact point in the middle. I forgot 0, 0. It goes right through there. Let's see. So what you can do is there's lots of alternatives. If you shift it, you can shift it any multiple of 2 pi. For instance, you can also put Y equals 2 sine 3x plus pi, because that's just changing the argument by 2 pi. It's 2 pi periodic. And then if you take out the pi and flip it upside down, that's the same thing, right? If you shift over half a period, flip it upside down, then you get the one that's on the back. Y equals minus 2 sine 3x, and take away half the period pi is also another one. So there's an infinite number of answers. These are 3 of them. You can try some others also. Well, looks like it's about time to go then. Come by and see me if you take an interest in help me get ready for the test next time.